So we have the forms of parabola. So we'll start with one, centered or with the vertex at the origin. How many forms do we get if it's centered at the origin? So far we have seen from the quadratic that there are 4. And so here I'll give you a very nice summary of it. So say forms. If I have y squared is equal to 4px, the other one, y squared is equal to negative 4px, and then x squared is equal to 4py, and the other one is x squared is equal to negative 4py. So if we have these 4 forms, we say the equation of axis or say the equation axis. So the axis where the equation is going to lie, if we have y squared is equal to 4px, then we'll say we're using the line y is equal to 0, meaning we're using the x-axis. Then what will be the directrix of this? The one we call the equation of directrix. Equation of directrix. So for this case, it will be on the x, which is equal to negative a. So in this case, I'll say negative p. So sometimes we use have 2 forms here. Sometimes you use y squared is equal to 4ax, or you use 4px, depending on which one you're comfortable with. And then the vertex for this case, we are saying centered or having the vertex at the origin, so it will be 0, 0. And then the focus, it will be a, 0. So from the vertex, if you have a sketch of this nature, in this case we are saying it's this thing. So if we put the focus here and we say this distance is a from the vertex, then to the directrix it will be the same distance, but now because it's a and going to the left, so we're going to say negative a. That's the reason why the equation of the directrix is negative p if the inner one is p. So if I have an equation of this nature, then I sketch, I say this is the graph, and then I put p here as the focus. Then the directrix is going to be the line x is equal to negative p. The distance from the directrix to the vertex is equal to the distance from the vertex to the focus. And then you also have the length of the latus rectum. The latus rectum, which is 4p. The distance that cuts, that touches the graph, the 2 points cutting through the focus. So this is for this type of an equation. When you have y squared is equal to 4px, then you have these properties for that. When they say discuss this parabola, this is what you must state. The next one, if y squared is equal to negative 4px, then we'll have the same axis. Y is equal to 0. The directrix will now change. It will be x is equal to p. The vertex will still be the same, is 0, 0. The focus will also change. It will now be negative p, 0. Also here we used a. It's supposed to be p. So it will be negative p, 0. And then the length of the lateral spectrum still standing for p. This is for the y squared. Now we go to x squared is equal to 4py. What will be the properties? This will be on the axis. This will be on the axis. On the x is equal to 0 axis, meaning the y axis. So this graph should look like this one. This is the graph we're talking about. Either it faces up or facing down. And then the directrix, it will be now y is equal to negative p. And then the vertex, we said 0, 0, the origin. And then the focus, 0, a. And then the length for p. If you have x squared is equal to negative 4py, you still get this is on the x-axis. I mean on the y-axis, where x is equal to 0, y is equal to p, the directrix, 0, 0. The vertex, the focus is then going to be 0, negative a. Distance still 4p. So how do we appreciate this? If you see the shape, so let's see the shapes for each. So the shape here, the shape here is the one on the right. So here we have sky facing this direction, with this being P, and then this line being negative P. So we're saying this is X is equal to negative P. And then the graph is Y squared is equal to 4px. For the next one, this is our graph. So we'll have now going in reverse, this will face this direction. It must touch the origin. And then this is negative P. So directrix then becomes positive P. So this line is a straight line. X is equal to P. And this graph is Y squared is equal to negative 4px. And then for the other one, so this graph, it's going to be facing up like this. With this guy being P, and down here we get negative P. So we're saying this graph is the graph x squared is equal to 4py, and this line is the line y is equal to negative P. And then the last one is pressing down. So this is negative P, and the directrix then will go up with positive P. So we say this is x squared is equal to negative 4 py, and this line is the line y is equal to P. The directrix, that is 0, 0 there. So these are the shapes that we expect to see. Okay. So if we go to examples of this, coming from question in the Toro sheet, question 1B. So that we have examples and see how we can easily appreciate this if we're asked to sketch this type of graphs. Or we can do a combined one. When we still have this one with the vertex at the origin, we also look at the one with the translated vertex, which is not at the origin. So what do we have? We also put a bit of some standard forms, so that then we can answer all the questions that are around the parabola, and then we'll move to the ellipse. So 2, vertex not at the origin. So also put them in video some standards. So say standard forms. So 1, the axis of symmetry. This is the same as saying the axis of the graph. And then we'll see the equation itself. And then how do we get the focus? And then the directrix, equation of course, and then just this part. So 1, if your axis is y is equal to k, the equation that you have is y minus k squared is equal to 4p x minus h. So that if the axis is x is equal to h, then you expect to have x minus h to be the one squared, giving us 4p y minus k. So if we have this, if you have the first one, which is sitting on the y-axis, the focus then becomes h plus p, comma, k. So that its directrix becomes x is equal to h minus p. If you have the one sitting on the x-axis, then you say, and then sitting on the y-axis, then you say the focus is going to be h, comma, k plus p. The directrix is going to be y is equal to k minus p. So the other properties, you can appreciate them from here. So you know now that the same properties here we've just put for 2, and then the other 2 are embedded in these 2. That is, if you have a negative or a positive. So you know what will change is just the orientation of the graph. So now we got the Cherry sheet and pick the questions from there that needs the parabola. Cherry sheet. So we have question 1. Or we can actually start from question 1. 1A. It won't take much time there. Question 1A. For each of the following, find the equation of the circle satisfying the given information. 1. If you are given the center is at -2, 1, and the circle passes through the point 1, 3. So if we are to put up a sketch of this is a circle and has a point -2, 1 as the center, and then it touches at the point 1, 3. So we understand that the distance from the center to the point being touched is the radius. So because the distance is a radius there, which we know that to get the distance between 2 points, if I have the 2 points x, y, and p, q, maybe we use the known ones to avoid confusions. If I have x1, y1, and x2, y2, then you say the distance between them is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. So the radius in here will be the distance between the center and the point that is being touched, 1, 3. So to find the radius, we'll use the same formula and say, oh, so r is going to be the square root of, if we say the inner ones, our x1, y1, and then x2, y2. Then when we get to this one, we'll say x1 minus y2, that would be -2 minus 1 squared plus 1 minus 3 squared, giving us the square root of -3 squared plus -2 squared. This is the root of 9 plus 4, which is root 13. Now the formula of a circle is x minus h squared plus y minus k squared is equal to radius squared. Now, since we have r there, we have r is equal to the root of 13. If we square both sides, we'll have r squared is equal to 13. What we want in the formula is r squared. So we'll get 13 and not root 13. So say, since the center is given, so in the center, we are saying this is h, k. So we know our h is -2. So just substitute here and say x minus -2 squared plus y minus 1 squared is equal to, we get 13. This is giving us x plus 2 squared plus y minus 1 squared is equal to 13. So this becomes the equation of the circle that is touching the point given and has the center -2, 1. Okay, then we got the second one. We are told that we should find the equation of a circle satisfying the given information. So what information is this? that it passes through the point 2, 3, 3, 2, and negative 4, 3. So here you say, okay, since I know the equation of a circle is x minus h squared plus y minus k squared is equal to r squared. And I'm told that this circle is touching 2, 3. It's also touching 3, 2. It's also touching negative 4, 3. So we know that this is our x, comma y. This is our x, comma y. This is our x, comma y. So if we substitute in here, the first point, x, comma y, where there is x, so say equation 1, where there is x, we'll put 2 minus h squared plus, where there is y, we put 3 minus k squared is equal to r squared. You can do the expansion here, where we'll get 4 minus 4h plus h squared plus 9 minus 6k plus k squared is equal to r squared. As our equation 1. And then the next one, equation 2, you take this point now, where there is x, we put 3 minus h squared plus 2 minus k squared is equal to r squared. Again, we expand, so we get 9 minus 6h plus h squared plus 4 minus 4k plus k squared is equal to r squared. Then equation 3, you take negative 4 minus h squared plus 3 minus k squared is equal to r squared. So if we expand this, what do we get? We get 16 plus 8h plus h squared plus 9 minus 6k plus k squared is equal to r squared. So now I want to solve these 3 equations simultaneously. So we pick 2 and then substitute. So you can go to the first one, do something to it, and then substitute in the other one. So suppose you got the suppose you go to the first equation and pick the value of the squares. So we say from the first equation, we'll have h squared plus k squared is equal to r squared. Then we take everything else the other side. So as we add 4 plus 9, 13. So it will go to the right as negative 13. And then this will go to the right as positive 4h. This will go to the right as positive 6k. So this is from equation 1. Then we substitute equation 1 in equation 2 and in equation 3. So equation 2 will look like this. So where there is h squared plus k squared, we'll put this whole thing here. And now we have h squared plus k squared. So as we add 9 plus 4 is 13, and then minus 6 h, and then minus 4k, and then on the h squared plus k squared, we substitute this whole thing, which is in r squared minus 13 plus 4h plus 6k is equal to r squared. This is in equation 2, which you can simplify. We simplify it, it becomes this 13 and this one will cancel. What else is canceling? And this r squared and this one will cancel. So we remain with we add negative 6h plus 4h, we get negative 2h, and then negative 4k plus 6k, we get positive 2k is equal to 0, giving us a very good relationship. If we take this to the other side, we'll have 2k is equal to 2h, then divide by 2, divide by 2. So what we'll have is k is equal to h. So in the next equation, in equation 3, we'll substitute this very part, this equation 1 in equation 3. So we'll have 16 plus 9, that is 25, and then plus 8h, and then minus 6k. Then where we have h squared plus k squared, we're bringing r squared minus 13 plus 4h plus 6k is equal to r squared. We also know that r squared and r squared will go. And then the other ones, they will simplify. Remember on the right now we have 0. So they will simplify. We'll have 25 minus 13. This is 12, positive 12. And then we have 8h plus 4h. That is 12h. And then this is negative 6k. And this is positive 6k. So here we get 0. So I've done it to everything. This guy is equal to 0. Now, if this guy is equal to 0, we know that k is equal to h. So what is happening? What is happening is that we have 12 h is equal to negative 12, giving us h is equal to negative 1. So I found the value of h. Exciting is that once we find the value of h, then we have the value of k because the two are equal. So we have the value of k as well. Now, after having the value of k, then what next? We now have the center. So we have the center 1, 1. Then we also have 3 points that where the circle is passing through. So we'll do the same thing of finding the radius. So say we can pick endpoint. So let's pick the first one, 2, 3. So say r squared is then equal to 1 minus 2 squared plus 1 minus 3 squared. This is equal to negative 1 squared plus negative 2 squared, which is equal to 1 plus 4, which is equal to 5. So the equation is going to be x minus h squared plus y minus k squared is equal to r squared. Now we have x minus 1 squared plus y minus 1 squared is equal to positive 5. So this is the equation of the circle passing through the given 3 points. And this is how easily one can solve this equation. Then now we go to question 2. Question 1.
Excuse me, sir.
Okay.
Won't it be x plus 1? Because our h is equals to negative 1.
Oh, yeah, you're right. So because our h is negative 1 and positive 1, so when you bring them in the formula, they're coming with their negatives. So have plus here and plus here. Thank you.
Sorry, just a minute. I'm lost where we got what? Okay, all right, I see.
Okay. So because it's just h comma k, so we have negative 1 comma negative 1. Okay, now let's talk about B, where we have a direct equation on parabola. B 1 is saying find the foci, vertices, and hence sketch the following. Okay, I'm going to see. In each of the following parabolas with a vertex at the origin, find the focus, directrix, and hence sketch the graph. 1, we are told the vertex is at the origin. So we go to the forms of the parabola with the vertex at the origin. X squared is equal to 2y. You know, the form of this one is supposed, because it's positive, the form is supposed to be x squared is equal to 4 py. So it means that the whole 4p is equal to 2. So we're looking for p now. This implies that p is equal to 2 over 4, which is 1 over 2. Then from there, once we have the value of p, then you look at the forms. Okay, so it's x squared is equal to 4py. So what's the line of the directrix? It has to be y is equal to negative p, which is equal to negative half. And then the vertex has been given, it's 0, 0. You've been told the focus. So the focus is supposed to be 0, a, which is 0, p, so that we get 0, half. Then you sketch. So we have our sketch. Our sketch is a half, and then the directrix and negative half. So the graph will be like this one. So once I have all the forms, it's very, very easy to sketch.
So, excuse me, sir, I have a question.
Yes.
When it is at the origin, the directrix is the opposite of P?
Yes.
All right, thank you.
Yes, purely the opposite of P, because the distance from the vertex to the focus is equal to the distance from the vertex to the directrix. Okay, so the video will be cutting. Let's join immediately. It cuts. We join back. We continue with this discussion.